Hey guys, Mr. Backerberg here. In this video, we're going to take a look at exponential growth. So as we're looking at an exponential function, we're going to let a be some positive real number other than 1. Then we can say that the function f of x equals a raised to the xth power is an exponential function with a base of a. Now, as far as this function goes, when we talk about its domain and its range, for an exponential function, it's going to be safe for us to plug in any number we want for that x value. So the domain is going to run from negative infinity up to positive infinity. As far as the range goes, though, because we're dealing with positive a values, when you raise a positive number to any power, you're always going to get a positive answer. So the range is going to be from 0 up to infinity, but 0 is not included. There's no way for us to get 0 as an answer by plugging numbers in for that x value. Now, depending on what that base of a is, it can affect the picture of the graph slightly. So if we're dealing with an a value that's greater than 1, then your graph is going to look something like this. And some people like to call this a J curve, because the graph kind of looks like the letter J. Now, if we change that a value slightly, now we want positive real numbers other than 1. So we've got numbers that are bigger than 1, but let's say that we had some number that was between 0 and 1. Then what that's going to do is horizontally flip this graph around that y-axis. And some people call this an L curve. So in this example, we're going to graph out an exponential function. We're going to draw a graph of the function y equals 2 times 3 raised to the x power minus 4. And once we have that graph drawn out, we're going to state the domain and the range. Now I'm going to use my calculator to help me draw this picture. So on my calculator, I already have the function typed into my y equals screen. I'm going to hit zoom 6 to get a nice picture of what this graph is going to look like. So we've got this J curve. Talking about the domain and the range, the domain is the x value, so we're reading this graph from left to right. The left side is easy to see. As we work our way out to the left, this graph is going to extend forever and ever and ever in that direction. But as far as the right-hand side, it might be a little trickier because we can't see too much of the graph happening on the right-hand side. Because of this J curve, what's happening is our graph is going up very, very rapidly. But what's going to be true here is as this graph keeps going up, it's also going to keep extending out to the right. So as far as the domain, that's going to run from negative infinity up to positive infinity. As far as the range goes, reading this graph from the bottom to the top, if we look at what's happening on the left-hand side of our graph, it's flattening out around that y value of negative 4. Now what's actually happening there is there's a horizontal asymptote at negative 4, and our graph never actually crosses through or hits that horizontal asymptote. So as far as the range goes, it's going to be from negative 4, not including negative 4, all the way up to positive infinity, because this graph would keep extending up forever and ever and ever. So again, we just said the domain for this function was going to be from negative infinity to positive infinity, and the range was going to go from negative 4, not including negative 4 because of that horizontal asymptote, all the way up to positive infinity. Now in this next example, we're going to be finding zeros of the function f of x equals 5 minus 2.5 raised to the x, and we're going to do that graphically. So I'm going to graph this out on my calculator. I already have that function typed into the y equals screen. So if I hit graph, I'm going to get a picture that looks something like this. We're finding the zeros, which means we're finding the x-intercepts, the places where your graph crosses through the x-axis. Now we've got an upside down J curve, and we're looking at the graph hitting the x-axis a little bit short of 2. To find that actual value, I'm going to go second trace, and I want to find a 0, so that's option number 2. And then I want to be on the left side of the 0. So if you're not already on the left side, just arrow over to the left a few times, hit enter. Then I want to go to the right side, and what my calculator does is it puts these arrows on there, and it's going to look between those arrows for any places where the function is equal to 0. It lets you take a guess, but you don't have to. You can just hit enter one more time. And this says that we've got a 0 happening at 1.7564708. Last thing that we're going to talk about are some rules for exponents. For these rules to work, we're going to let a be some number greater than 0, and also b is going to be some number greater than 0. All of these will hold true for all real numbers x and y. So if you've got a raised to the x times a raised to the y, notice that a is the same on both of those, then what we can do with that is add those powers together. So for example, if you had 2 squared times 2 to the 5th power, we can add those powers together to get 2 raised to the 7th power. There's a similar rule for dividing. So if you have a to the x divided by a to the y, you're going to subtract those powers. So if we had 2 to the 5th divided by 2 squared, what we would do is subtract top power minus bottom power, so that would give us 2 cubed. If you've got a to the x and you raise that to another power y, or if it's the other way, it doesn't really matter the order, a to the y raised to the x, you're going to multiply those powers together. So if you had 2 squared and then raise that to the 5th power, we would multiply those powers together to get 2 to the 10th power. Next one says if you have a to the x times b to the x, so your bases are different, but your powers are exactly the same, then what you can do is multiply those bases together and then just put that 1 power on that answer. So for example, if we had 2 squared times 3 squared, what we could do is take 2 times 3 and raise that to the 2nd power, so that would be 6 squared. And then our last rule, if you've got a fraction, a over b, being raised to the xth power, then what you can do is put that x power on both the top and the bottom. So if you have 2/3 squared, then you can write that as 2 squared over 3 squared. That's going to be it for this video. Thanks for watching.